function with the values, then that's okay. Okay, so there are no more questions. Then I'm going to present you very shortly. It's a really short thing. It's the binomial set. So, first off, is anybody taking statistics and can tell me what a binomial set is? Or what the binomial distribution?
There's two options, like either true or false, and you have a set number of tries, and there's a set percentage of it being either true or false, right?
Yeah.
And then it's a distribution if you throw it once or twice.
Okay, good. So so a binomial distribution is, one example of it is, for instance, say you flip a coin, and every time you flip a coin, of course, you have the same chance, unless you can really control the air particles around the coin and the trajectory and everything. And it's gonna happen. It's gonna be more or less the same chance of it hitting or getting heads or tails every time. So if you have that, then you can make what's called a binomial distribution, which says that basically if you try n times, and this is a density thing, so imagine a histogram. It's gonna look something like this. So if you try n times, then you'll get heads this many times, and of course, every time, it's not going to tell you deterministically how many times you're going to get heads when you flip a coin, but it's going to tell you more or less how many times you should expect. And for instance, if you get heads 99 times, then there's a really big chance that the chance of you getting heads is not 50%. So what I want you to do, and I guess we're not going to have time. If you want, a binomial distribution also gives an estimate of the number of times that you have to do something in order to just get it once. So for instance, in a binomial distribution, if you have a 20% chance of a 20% chance of winning the lottery for some reason, you're a very lucky person, then you should, if you play the lottery 5 times, there's a 50% chance that you will have won the lottery in one of those 5 times. So, at least one of those 5 times, rather. So what I wanted you to do, but it looks like we're not going to have very much time, is to flip rands. And keep on flipping the rands, so say rand, and stopping when you got the first value of your rand. That's the one that's in a range that you want. So for instance, let's say that I tried to simulate a binomial distribution with a probability of 10%. So we'll have x equals rand, and what's one way I will have a 10% chance of getting something? How can I test for something with a 10% chance using x?
X is less than or equal to 0.1.
So that's one example. Yeah. So we can have and this looks like something that you'd put in your while at the your while loop, right? Because a while loop checks for condition, or maybe an if statement. Yeah. So what I wanted you to do, and I guess you're welcome to leave pretty soon, but is give me a program that will simulate and run a binomial distribution. So, and basically it'll do this, it'll try flipping rands, and then stopping when it gets a rand, and it'll have recorded the number of times that it's tried to get it. If that makes sense. So, you know, say that it flips a coin 50 times, or 50 times before it gets a heads. Then it'll say 50, and then it'll store that value somewhere, and then compare the results to the expected results. But since we don't have time, I guess class is dismissed. If you don't have any questions, if you do. Yes.
Regarding the lottery, the lottery extra credit, I have it running the 10 million times, and I'm still getting different values for each time I run it.
Well, it's
I ran it 4 times here.
Yeah, like when I do it, I go listening and
Right, but he wants it to 8 decimal places. And these are varying around the world.
I'll have to look at these. I heard of it.